All right, so moles of oxygen per moles of carbon dioxide. Again, I'm going to my chemical equation. So I have 13 moles of oxygen per 8 moles of carbon dioxide. Same thing for O2 and H2O, 13 moles of O2 for every 10 moles of oxygen, etc., etc. So when you're setting up these mole ratios, you've been seeing me write it on the PowerPoint slides, 2 mole C4H10 per every 13 mole O2, okay? It makes a little bit more sense when they're up and down because you can actually look at how you're going to cancel out your units. All right, so again, forgive my setup here. I don't have a ring stand or anything to kind of hold my cell phone for me here. I'm just kind of winging it. It's sitting on top of a thing of Clorox wipes, just in case you were wondering. But we got to make do with what we've got. So here's my following equation. I've got potassium chlorate, potassium chloride, and oxygen. It is balanced for me, okay? And it's asking me how many moles of O2. So right here, if it's asking me how many of something, that is my desired substance. Can be produced by reacting 12 moles of KClO3, potassium chlorate. That's my starting substance. So when we're setting up stoichiometry equations, so I've got 12 moles of KClO3, and I'm going to multiply that by my mole ratio, these guys. So my desired substance, which is O2, I have 3 moles of O2 per every 2 mole KClO3. And then it's just an equation at that point. Now, cross out my like units, and then I just have to find a calculator, which is right in front of me. Punch that into a calculator, and I end up with 18 moles of O2. Remember, this is my only unit left. So this is why Mr. Cree and I were banging your heads against the wall, more so our heads than your heads, about units and about setting up the problems properly so that this transfers nice and easy, okay? So let's do another example here. So here's my equation. So I have potassium and chlorine, gives me potassium chloride. So it's asking me how many moles of KCl, so how many of something, that's my desired substance, that's going to be the top of my mole ratio, is going to be produced from 2.5 moles of potassium. So I start with my starting substance, which is right there, and I multiply it by my mole ratio. So I start with my desired substance. According to my balanced chemical equation, I have 2 mole of KCl for every 2 mole of potassium. Now, this is kind of nice because any number divided by itself is going to be 1. So I really don't need a calculator for this. So if for every 2 moles of potassium chloride, there's 2 moles of potassium, this is going to be 2.5 times 1 equals 2.5 mole of KCl. Okay? That's how you solve these one-step equations. All right? Let's do this one down here real quick. How many moles of KCl is my desired? 10 moles of Cl2 is my start. So I start with 10 mole of Cl2. Multiply it by my mole ratio. I have 2 moles of KCl2. No, there's no 2 there. Over. There's nothing in front of that Cl, so it's 1 mole of Cl2. Put this into a calculator. 10 mole times 2 over 1, which just means it's 2. So 10 times 2 is 20 mole of KCl2. Cl. There you go. Those are one-step equations. This is what I mean by writing these things out. When you write them out, you can synthesize them. You can embrace them a little bit better, okay? Next video, we're gonna tackle the two-step and not the dance, because I only dance when necessary.